Welcome to this video learning session. When you complete the session, you will be able to calculate a project's present value. In this session, you'll learn what present value analysis is and why it is important, how to calculate present value, and how to use Microsoft Excel to calculate present value. Present value analysis adjusts future cost and benefit amounts depending on when they occur. To understand this, let's review a concept called the time value of money. The time value of money means that a dollar you have today is worth more than a dollar you get a year from today. If you have a dollar now, you can invest it and it can grow in value. So if you're going to receive benefits, it's better to get them sooner rather than later. The same concept also applies to future costs. Suppose it's January and you have a savings account. Would you rather withdraw money to pay a bill early in the year or toward the end? The longer you can keep the money, the more interest it earns. Let's use an example of getting $100 on January 1st and investing it for a year at 6%. To calculate the 2012 value, we multiply 100 times 1.06 to get $106. Now let's go the other way. Suppose we know we are getting $100 a year from now, and we want to know how much that is worth in today's dollars. We would divide the future amount, $100, by the rate of return, 1.06. $94.34 invested today at 6% will turn into $100 in a year. So $94.34 is the present value of $100 a year from now. To calculate present value, you estimate benefits and costs and when they will occur. Next, you remove the timing differences by using adjustment factors. Then you can evaluate the adjusted costs and benefits accurately, no matter when they actually occur. Let's continue the example, but reduce the future amount from $100 to $1. The result is a decimal factor, also called a discount rate, that we can use to adjust benefits and costs to present values. What about adjustment factors for other rates and time periods? This table shows factors for various rates and time periods. For example, we know that next year's dollar is worth only 94 cents today. What's interesting is that if you have to wait 5 years for that same dollar, it's only worth about 75 cents today. And if you have to wait 10 years, the value is almost cut in half. You can find tables like this in the textbook and on the web. Here are yearly costs and benefits for a proposed information system. Now we'll enter adjustment factors from the table using a 6% rate. With the factors filled in, we are ready to multiply dollar amounts times the factors. Notice the factor for year 0 is 1.0 because year 0 is the present value. After adjustment, the original benefits of $90,000 are worth only $79,160 current dollars, and the expenses of $60,000 will only cost $56,570 current dollars. All costs and benefits now represent their present values, regardless of when they actually occur. When you subtract costs from benefits, the project is worth $22,430 current dollars. That is the project's net present value, or NPV. Notice the impact of timing. If costs come later or benefits come earlier, present value will increase. And the opposite is true. Heavy initial costs or slower benefits will reduce present value. Adjustment factors also reflect the rate of return assumption. Higher rates require more adjustment for the time value of money. Theoretically, at a zero rate of return, timing would not matter at all. Unlike payback analysis or ROI, present value does consider cost and benefit timing. However, some managers feel that present value calculations are complex and that rate of return assumptions can be subjective. In Part 3, you'll see how Microsoft Excel can help you calculate present value. Using Excel, the first method is to create a spreadsheet and simply enter the adjustment factors from a table. The benefit formulas in cells C7, D7, and E7 multiply the factor times the dollar amount, with totals in column F. The cost formulas in row 11 use the same approach. When you subtract total costs from total benefits, the net present value displays in cell F13. The other method is to use a built-in Excel function called NPV, which automatically applies the correct adjustment factor for you. First, create a spreadsheet with cost and benefit data, something like this. Notice cells H5 and H6. That's where the NPV function will go. Next, select cell H5 and click the Function button on the formula bar. Select the NPV function and you'll be prompted to enter a rate. We'll use the 6% rate, so enter 0.06. Now enter the three benefit amounts: $20,000 for value 1, $30,000 for value 2, and $40,000 for value 3. When you click OK, the benefits NPV displays in cell H5. Now follow the same method for the cost amounts. Finally, when you add the year zero costs of $30,000, the NPV of $22,422 displays. Let's take another look at the results. Here's the original spreadsheet. And below it is the sheet created with the Excel NPV function. Notice there is a slight difference in the values because Excel uses more decimal places. The difference is not significant. In this session, you learned what present value analysis is and why it is important, how to calculate present value, and how you can use Microsoft Excel to calculate present value. For more information, you can refer to the textbook or your student study tool. Now it's your turn to apply your skills and check your work. For background information, tasks to complete, and sample answers, go to the Management Information Systems CourseMate at www.cengagebrain.com. Select this text and navigate to the video learning sessions. Thanks for attending this video learning session.